Hello everyone, welcome to my channel. Today I will be discussing about a molecule Lunresertib. Here is the chemical structure for the molecule. This is an investigational drug which was developed by Repair Therapeutics for the treatment of cancer. Now I will discuss about the synthetic route for this molecule. First, I will discuss about the medicinal chemistry route, how they synthesized. They started first palladium catalyzed Buchwald-Hartwig coupling between this dimethyl dibromopyridine and this methoxy dimethyl aniline derivative. So here you can see the most reactive bromide underwent this coupling reaction, and the remaining bromide was replaced by the reaction with malonitrile and followed by an palladium catalyzed intramolecular cyclization reaction to afford this azaindole intermediate. And here this nitrile group has been hydrolyzed by using methane sulfonic acid in presence of sulfuric acid to convert into this carboxamide. And without isolating this intermediate, they treat it with this DL-methionine. Here is the structure of this amino acid DL-methionine. By treating with this reagent, they have performed this demethylation. You can see it has been converted into this phenolic intermediate 7. Now, this molecule is actually a racemic molecule. So it contains two different isomers. Those two different isomers they have separated by using chiral SFC. SFC means supercritical fluid chromatography, where carbon dioxide is used as the mobile phase. And through this SFC they have isolated this desired S isomer. So this molecule is a chiral molecule without having any chiral center. This chirality comes because of axial chirality. So this is called atroph isomer. Now in this process there were several problems, like solubility, very low solubility of this molecule, and that's why it was difficult to purify those two isomers through chiral SFC. That's why they have done some modification, like after getting compound 7, that phenolic intermediate, they have performed Bock protection reaction using Bock anhydride in presence of DMAF as the catalyst. Now this intermediate had better solubility. They have done SFC mediated chiral enantiomer separation and took that desired S isomer of this Bock protected compound, and at the final step they performed this de-Bock reaction using sulfuric acid to get this final compound. However, you can see here also they use this chiral SFC. Now this method was good for small scale preparation of this compound, but for very large scale preparation of this compound, this process was not suitable. So they have done further development that I will discuss in coming slide. So they targeted to get the pure enantiomer by recrystallization through salt formation. So the approach was like they would take a racemate compound 2. Compound 2, here is the structure you can see. So this is the nitrile step molecule, and they would treat with some chiral acid so that it can form two different diastereomeric salts. One is R isomer, another from S isomer, and then selectively they would do crystallization, and one particular isomeric salt they could separate by filtration. So that was the approach. So by taking this racemic molecule 2, they have tried approximately 25 chiral acids to get that salt, but actually most of the chiral acids failed to give that salt. Only when they used this S-camphor sulfonic acid, that time they got crystallization, but it was like 15:85 ratio, and 85% was actually R isomer, which was undesired one. So immediately they switched to R-camphor sulfonic acid, and the anisole they have used as the solvent, and they got the desired salt from this S isomer of this racemic molecule, and enantiomeric ratio of the recrystallized material was like 90:10. So here I will discuss the overall modified process what they developed. First step reaction they kept same, palladium catalyzed Buchwald Hartwig coupling. Second step also same, reaction with malonitrile followed by cyclization to get this nitrile. Earlier here they performed this hydrolysis of this nitrile group, but here before doing that one they treated with this R-camphor sulfonic acid in anisole solvent followed by recrystallization to get this chiral salt. Intermediate 8, and here they treated this intermediate with this methyl sulfonic acid, and without isolating this carboxamide they treated with this DL methionine for this demethylation and getting this molecule as the crude material. So here in this crude material they got approximately 97.4% chiral purity. So that they did further recrystallization using methanol and water, and they could enhance the chiral purity up to more than 99.5%, and the HPLC purity of this molecule they obtained more than 99% to get this final molecule. And by following this process they could synthesize 30 kg of the material. Thank you.